Yeah.
So I did the graph with y equals 1 over x and y equals negative 1 over x, and I used squares to approximate the cross-section. And I took the volumes of each of the individual pieces by using a basic ruler, and I wrote them on there. And the value I got was approximately 105.6 cubic inches.
Okay.
And I found my analytical answer, and I was a little bit unsure of how to convert it because I had 3.2 cubic units, and I wasn't sure how to convert between the two. And I realized what I had done was I had different scales in the x and y axis, on x and y axes. So instead of cubing the 2 inches per 1 unit, I had to do 2 inches times 4 inches times 4 inches to get 32. And then I multiplied that 32 by 3.2, and I got an answer of 102.4 cubic inches. So I have a discrepancy of about 3%.
Fantastic accuracy, and that is the part you were struggling with is in some sense the hard part, because you've got to make your scale. It seems to me a lot of you guys are going to be engineers, and going from the model to the real world is going to be one of the most difficult things you have to do. So nice solution to a good problem. Okay, Trevor, you want to try here?
All right.
Yeah. Okay, hold it up. Angling this down doesn't work as well. Yeah, now tilt it so that we get the full effect of it. Yeah. Okay. Let me zoom in a little bit. No, a little bit higher. Okay. So what have you got there?
So my model is a parabolic pyramid where you have square prisms, 16 of them going from x equals 0 to x equals 4, and the scale's in inches. And these are 16 pieces around a quarter of an inch thick. And the total volume of these is 34 inches cubed. When you add them all together, and if you take the integral from x equals 0 to 4, you get 32 units cubed, which is roughly 6.25% error.
Yeah, very nice. Okay, now did anyone spot the thing that he said that was incorrect? You said you called it a parabolic pyramid. Yeah, and
I'm not sure what, it didn't really say a name for the shape.
Yeah, that's the thing. A pyramid is a very specific thing, and I like the idea that you look at it and it's kind of coming to a point. But in order for something to be a pyramid, you have to have a base and one point and lines going to that point.
Yeah.
So it
just appears that way.
Yeah, you could say this is like a parabolic pyramid, but the vocabulary, words mean what they mean, and it's dangerous to have them use them in a way that leads somebody to think you've got something official. But no, very nice. Yeah. Good. Okay, Alexis, stand up here. Okay.
So this is my model.
Yeah.
I did the equation.
Yeah. Tilt it a little bit more toward me and hold it a little bit higher. There we go. Okay.
I did y equals the square root of x, and so I had to do both above the x-axis and below, so it's also y equals the negative square root of x. And I just measured my foam board and divided my scale. Oh, my cross-section is isosceles right triangles.
Okay, isosceles right triangles with, it looks like the
hypotenuse is the base.
Which you could have done differently, so it's important to say what you have. Great.
My hypotenuse is my base.
Yeah.
So I divided the scale by the foam core, which is change in x, and then I just measured each one of them out, the legs, and then built mine.
Okay, great. Okay, let's say, Ilana, try you here. Okay. Yeah, oh, a little bit higher. That's it. Okay, great.
Okay. So I had a circular base with isosceles triangles
Mhm.
as the cross sections. For my isosceles triangles, the base was equal to the height.
Mhm.
And the base is what is the base of the cross section. So
Sure, okay.
yes. My equation was x squared plus y squared equals 1, and so when you took the interval from -1 to 1, it was equal to, well, approximately 4.5911, and my volume was 4.472, so the percent error was 0.596%.
Oh, yeah, very nice. Yeah, good. Yeah, I like this percent error business. Somebody's been teaching you that, and it wasn't me. So, the physics class? Good. Okay, William, yeah, come over and yeah, stand in front of Alana. Yeah, so.
Parabolic.
Oh.
I had the parabolic, the ellipse, x squared divided by 36 plus y squared over 12 1/4 equals 1.
Okay, now tilt it right vertical, and yeah, let me zoom in on it here.
A delta x is in 3 divided by 16 inches is my delta x. The scale's in inches. The cross section was, for my cross section, to find the cross section, I subtracted the x squared divided by 36 from 1, multiplied by 12 1/4. Took the square root and then square the whole thing back in terms of pi divided by 2 r squared. To get the cross section being delta x multiplied by pi divided by 2 multiplied by the sum of 12 1/4 minus 12 1/4 x squared over 36 to my y. Right. And the integral from x equals -6 to 6 I found was around 57 inches cubed, approximately 57 3/4, and I found the volume of the model by the Riemann sum to be 56 3/4 approximately.
Yeah.
So I'm only off by about a cubic inch.
Yeah, you're not doing percent error?
I didn't think that.
Yeah, okay. Yeah, that you understand that percent error is a whole lot more meaningful. Clearly, you
I
can't.
can find that right now if you wish.
No, well, put it on your paper. I have not been stressing percent error, but I really like it because it does tell you. Okay.